All right, recording. Okay, I'm gonna do that again. Hi, everyone. Welcome to the workshop. If you haven't signed in yet, feel free to do so via the QR code. And with that, I'll get started. So first, I'm gonna give a little bit of an introduction. My name is Matthew deguzman. I'm the VP of Tech Events here at ColorStack UF, and I'm a fourth year computer science major. And just some background, I've had a few internships at Microsoft before, but now I will be going to Datadog in New York once I graduate this summer. And yeah, I've been doing this for about a year, so I hope you guys really enjoy this. Cool. So again, on the agenda, right, I'm going to be giving an overview on what deguzman.cloud is. Then I'm going to be going over what system design is and the deguzman.cloud design, as well as the system design resources. Um, yeah, I think I'm going to share my screen on the Zoom because I never did that. Cool. Share. All right. Wonderful. Just making sure that I'm actually recording. All right. Yeah. Okay, cool. I am recording. Nice. All right. Section one, deguzman.cloud, right? Here's just a little quote to leave you all inspired, right? An engineer builds for a quarter what any fool can build for a dollar. Unknown, but I found that quote to be very powerful and inspiring, and it is what I took into consideration when I built deguzman.cloud. So here it is, right? Deguzman.cloud is a cluster of servers, but with three Raspberry Pis, and I have a ton of services that I have hosted. For example, the landing page, which is what you see right here. I have my senior project on there. I have a Minecraft server. I also have a blog. If you haven't checked it out, feel free to do so. I post great content. I have a really good one cooking up. So yeah, if you also want to subscribe to my newsletter, come up afterwards. It's invite only, so you have to know someone to get in. I also have a static file server, a QR code generator. It's pretty useful, right? That QR code you saw at the beginning, I generated with the QR code generator, and I also use it for my DSA discussions. And there's a whole lot more that I didn't even mention. I've been sort of self-hosting this since about like October of last year. So every sort of week, I just find something new to put on there. Cool. So I built that, right? But again, we should always ask why something was built. So the first one was I was tired of cloud computing costs, right? Every time I wanted to deploy a Vercel uh, project, you can only deploy so many. You can only have so many databases on there. And so you hit the free tier, and then you're stuck paying $20 a month. And then you're sad because Vercel's taking all your money. Uh, and the second thing is that I have more control over what I deploy and how it's used, right? If I were to use Vercel, or more specifically something like AWS, right, then I leave it in the hands of, ooh, big tech. No, 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 right? Don't trust them. They can do whatever they want. But with this, I have more fine-grained control, which is pretty nice. And then lastly, I think it's cool, right? I think it's really cool to be able to tell people, hey, check out my blog or check out deguzman.cloud. Maybe we'll get even some merch, some really good branding. Yeah, I don't know. This thing could really take off. But yeah, I don't know. I just find it really cool, so I just decided to build it. And sometimes I think that's all you need to build something. But this is also very practical. Cool. So that was the Guzman.cloud. Now we're going to be going a little bit more into the system design aspect of this workshop, which is going to be majority of it. So first, right, what is system design? Some of us may have never heard of system design. I know I didn't until about like last year. And I got this really nice quote from my friend Wikipedia, and he said that system design is the understanding of component parts and their subsequent interaction with one another. And what that means, specifically in the context of computer science and more specifically software engineering, is understanding what components you need to have a system up and running, and more specifically, have it be scalable and performant. And we'll go over what that means in a bit as well. But just to give a very brief and concise definition, right? Basically, what components of your software system need to exist and how do they interact with each other, right? And why system design? This might be pretty obvious, but again, it's always good to ask why. First one is good to plan the architecture of the software, right? Before you go in and just start coding it up, you're going to want to think about it, right? So it's always good to architect that. as well as consider the constraints that you have as you build, right? Maybe you have a ton of people who are going to be writing to your system, right? Maybe you're doing some sort of messaging app, and a lot of people are going to be sending messages, which will be doing a lot of writes on the database, right? And so you're going to need to design your system with those constraints in mind. But then also maybe in terms of money, right? Maybe we're strapped for money, so we have to figure out how to make it make the system as performant, scalable as possible with only, I don't know, maybe a couple $1,000s. And it's also giving a clear map of how your system works, right? Maybe whenever you onboard someone new to your team, they're going to be like, okay, how does any of this work? Go check out the system design, right? There's obviously a lot more reasons for this, but I think these are the ones that I came up with when I was making this. So cool. So system design components, right? What makes up the system design? Uh, and we'll see. I'll just go over like the major ones here. There's a lot more, but I didn't want to spend an hour just going over all of the components. But yeah, the first one that I'm going to talk about is the load balancer, right? So what is the load balancer? It essentially takes a bunch of requests and it distributes them to a set of servers that you gives it, right? And this can act as a stress reliever. So maybe you have about 5 servers, right? But only 2 of them are capturing all of the requests. And that's bad because you have 5 servers, but only 2 of them are capturing or doing most of the work. And so you want that to be spread out sort of evenly, because, right, if only 2 of them are doing work, then there's a couple of disadvantages to that. So the first one is you're just not using all of the servers you have, right? Maybe you're paying more money for that and you're essentially just paying for 2. Or you're paying for 5, but only getting the use of 2. So a load balancer can help make sure that you get the power of all of that. The others is, if there's a lot of load on only a couple of servers, maybe it might just crash, right? Maybe it might run out of memory. It might go too far, push itself, overheat, right? There's a higher probability of failure if only a couple of servers are doing all of the work, specifically if there's a lot of load on your system as well. And then lastly, right, there's a lot of algorithms for distributing load, right? I've kind of just been saying the load balancer distributes load without saying how. Um, but yeah, there's a lot of ways of actually distributing that. Some are very simple, like round robin. If you guys have taken operating systems, you may have heard of like the round robin technique with scheduling, right? You essentially just pick whichever server you want, and you just do that in a circle or in a cycle. And yeah, then you might do it off of some more concrete constraints, sort of like the I/O, right? Maybe you want this to load balance based off of whichever server isn't using a lot of memory or isn't doing a lot of writes. And so you'll consider that within your algorithm. Um, so yeah, these are kind of the main points that I wanted to highlight. And then I have some pictures here of some load balancers. Nginx is a very popular one. So this is what's known as layer 7 load balancing. Layer 7 refers to the 7th layer in the OSI model. If you're familiar with networking, if you're not, don't worry. All it means is it just takes your HTTP request and it just decides which server to send it to, again, based off of your request. And then HA proxy is also another layer 7 load balancer. I just put these here because those are the 2 most popular. Yeah, I use Nginx for deguzman.cloud. It's pretty easy to set up. I haven't checked out HA proxy, but I know it's a thing. So if you're interested in using HA proxy, uh, I don't not recommend it. Uh, Also very popular. So cool. So the second thing, the database, right? And the database, there's a lot that I can say here, so I probably will. The first thing is this is where you just store data, right? It stores persistent data that you're going to need for your application, right? Maybe you want to store a list of all of your users, as well as like their passwords that you can help with their authorization and authentication. Maybe, for example, Instagram, right? They need to store all of the photos that you post so that when you go back onto the app, they're not all completely gone and you don't have your wonderful pictures of you in Italy completely removed from existence, right? So they're going to use some sort of database solution for that. And there are several kinds of solutions that you can use, right? The first is SQL, and the second is NoSQL. Now, I'm sure you guys are all familiar with SQL, especially if you guys are in databases right now. You guys only go over relational databases, which is what a SQL database is. It uses structured query language to sort of, you know, create the schemas for the data, as well as querying them. And yeah. Uh, so some people don't use SQL, right, because it requires you to define the schema for all of your data. But some of the data for an application may be more free flowing and isn't necessarily going to be restricted to just records and whatnot. So they might opt for NoSQL, right? And in that case, you might use something like MongoDB or Cassandra. Those are two pretty big NoSQL databases. But NoSQL databases aren't just restricted to document databases, which is essentially what MongoDB is. Um, and if you're not familiar with MongoDB, it just stores your data as JSON, right? And that's pretty easy to work with, but there's also a bunch of other NoSQL databases. It basically just means you're not using SQL, right? So if you're familiar with object storage, right, that's probably where your photos are going to be like posted or stored in by Instagram. You're not really going to be putting an image in SQL. Um, so yeah, you just have an object store. There's also a bunch of other things like graph databases. It maps your data like a graph. If you guys have all taken DSA, then I'm sure you guys know what a graph is. And that's kind of niche right now. Not hasn't really taken off, but it's on the come up. And then, more for ML, there's this thing called a vector database, right? I'm sure if you're familiar with embeddings, it's really good for just contextualizing data and seeing how similar it is to one another. And yeah, those are all examples of NoSQL databases, right? But I just put like the first ones that come to mind for SQL and NoSQL, and the ones that I thought were the most popular, right? So the first one that we have is Postgres right here, and then MySQL. Those are both relational databases, and they both use SQL, right? There's some small distinctions between them, but I think the biggest distinction is that Postgres is just a little bit more advanced as opposed to MySQL, and it just has a little bit more features. And then Cassandra, I think that was made by Facebook, and then MongoDB was made by MongoDB, and they are both NoSQL databases. I think Cassandra is also a document database as well, so they just kind of store documents like JSONs and whatnot. And so you might be asking, why would I use a relational database over a or a NoSQL like document database, right? And the first one I kind of mentioned already is that if you don't want to have a predefined schema for your data because it just fits your application better, uh, then you can use MongoDB or Cassandra, right? But that's not the only reason. Um, Something you want to consider is the scalability, which we'll get into later. But essentially, what I want to say is if you want to add sort of more instances and shard your data. That's a lot easier to do with MongoDB or just these NoSQL databases as opposed to these relational databases. And that's because they have a set of constraints that they need to keep up with. So, for example, I think one of the things that they prioritize is consistency. So, whenever you write to some database, it's going to need to be reflected to all of the replicas across the other instances of your server. And that might take a little bit, right? It might only be like a couple of milliseconds, but depending on how mission critical your system is, that might be too much. So you might use something like MongoDB or some other NoSQL database for that. Cool. So another thing is caching, right? Databases are great. The ones I just mentioned can take you really far, right? Like Postgres and MongoDB. But the thing is, they can be a little bit slow sometimes. And to mitigate that, we have the cache. So caches are typically very quick because they store their data in memory. So if you remember from computer organization, right, there's the computer memory, and then the CPU has its own sort of cache, right? There's the L1, L2, L3, all of that. And you remember that at each layer of the cache, right, it's always just faster than the one below it. And in this case, right, memory is going to be a lot faster to retrieve and write data to and from as opposed to just hard disk storage, right? Or maybe even an SSD, right? SSDs are fast, but still not as fast as what we have for just straight up RAM in our memory. So yeah, a lot of these caches are also known as in-memory databases. Um, and yeah, they're really quick, right? They can do it in a couple microseconds, just grab your data very quickly. And some use cases, right? Obviously, if you have like a small amount of data, maybe you can just use your cache as like your entire database. Wouldn't entirely recommend that, but it's possible. But some use cases, you can return the frequently accessed data with low frequency, right? So maybe a lot of users or your system is just pulling a lot of the same data from your database. And instead of overwhelming your database with all of those same reads, you can just offload it to the cache. And some advantage to that is now your database isn't getting as much load, but now it's also getting returned a lot faster because it's not just sitting in the memory. It's now sitting in this, or it's not sitting in the disk, it's sitting in the in-memory cache. Um, and another thing is that it can sit between the database and the client to relieve the database load, like I just said. And there are just a lot of use cases for that. I won't go into all of them, right? But some of them are called like look aside or look through. Um, but the overall picture is that you have the client, you have the cache, and you have the database, and it just holds whatever memory that you have within it. Um, and so with the cache, right, there's a lot of things you can also think about. For example, I think it's called, what was it called? When you want to remove the data, right? I forget the exact word, but how do you go about that, right? So a lot of things to think about with caches. And so the two caches that I have up here are Redis. Redis, I think, started out as a cache, but it can do so much more as well, and that we'll get into later. Um, but yeah, there's Redis and then there's also memcached. The differences between these two is that memcache is purely just key value, right? And by value I mean just the value. Whereas Redis can handle key and then not just like a simple value, it can handle like more complex data. So maybe you want to have a key and then a JSON. Redis can do that. Memcache isn't really able to do that unless you want to store it as like some sort of string, um, but that might not be as efficient. So yeah, what's up? I don't. Yeah. I'll talk about why later. But it mostly has to do with me being the only user. So, yeah, but not for long. Not for long. Maybe I'll. Oh, well, talk to me after class. Yeah, I'll get you. All right. Okay. So, next thing I want to talk about is the async component, right? And this is more specifically known as task and message queues. So, you guys are all familiar with queues, probably learned it your first year of computer science, right? And so here's a little bit more on what I mean by queuing. So we have some jobs or messages that are on queued by clients. So this might be some server responding to your request, and then it might on queue something onto this async task message queue. And then the message is eventually dequeued by some worker who then processes your job. And the main reason that you'd want to have this, right, instead of just handling it all on the server, is that maybe there's a very expensive job that you need to do, right? Maybe you're, I don't know, doing some sort of video or like audio encodings and whatnot, and that can take a while to do on the server, right? It may take like 500 milliseconds to do, and that might be a lot depending on your use case, right? Maybe you get a lot of these requests, and now your servers are just taking a while because they're getting these thousands and or maybe even like hundreds of thousands of requests, and they're taking pretty long to respond to, which just means that they're going to be less available because they have less time to actually respond to stuff because they're just spending more time working. So you can offload that with these task message queues. And so that's why I have this delayed processing here, right? So instead of the all the work happening on the server, right? All that happens is that the server receives your request, then it just gives it to the queue, and then it just ends. And now it can just wait for more requests to come in. Um, yeah, pretty simple there, but this is also pretty widely used, especially in a lot of systems that require this heavy processing. Cool. So I taught you guys about some pretty important components. Now you guys need to just know how to actually use these and what you should prioritize when you are designing a system that you want to be scalable and performant for. So the first thing I want to talk about is the difference between scalability and performance, right? So I've been saying scalability a lot, but what actually is it? So a service is considered scalable if it results in increased performance in a manner proportional to resources added. So essentially what that means is if you add more machines to your system, it should perform better, right? It shouldn't perform worse or just the exact same. That's not considered scalable. And you eventually want this because let's say that you're at some super cool startup, right? Maybe you guys only have 1,000 users and you maybe only have like one database and like one server responding to the requests, right? But then one day you guys blow up. I don't know, Elon Musk retweeted something or I don't know, something crazy happened, right? And all of a sudden you guys have 1,000 users to 1 million users, right? That's going to be a lot. If your system isn't scalable, it's going to explode, not literally, but you're just going to get a bunch of 500 errors because your servers are down. People are going to think you're unreliable and your startup loses all its money and it's bad. So you want your designs to be scalable so that all you can do is just, add a couple more servers, add a couple more databases, and boom, you can handle these millions of users. And what's great about this is that a lot of cloud providers have this like auto scaling ability there. So you can just turn that on. And if you designed your uh, system correctly, when it adds more machines, your system is also more performant. Uh, cool. And now performance, right? I think this is a little bit obvious, but I just wanted to put it here. So it's basically how well your system operates under some metric. Usually it's something such as time, right? So how fast does my server respond when I give it this request? If it's about 500 milliseconds and it's doing something pretty simple, it's probably bad. But if it's within a millisecond and it's doing something relatively simple and that's good for you, then that's good for the system as well. Cool. So I guess actually one thing I wanted to talk about in terms of scalability is the difference between horizontally scalable and vertically scalable. So those are two words that you'll kind of see thrown around a little bit. Vertically scalable essentially means that when you have a machine, you want to maximize the amount of resources that it can handle. Um, and horizontally scalable essentially means you're just adding more machines, right? So if I want to vertically scale one of my servers, I might just add more RAM, or I might just add more storage, or I might upgrade the CPU. But if I wanted to horizontally scale, I would just add more servers, right? Um, and you might be thinking, why not just horizontally scale all the time, right? Sometimes that's just not feasible. For example, with the databases that I mentioned before, SQL databases are notoriously hard to horizontally scale. So typically you vertically scale before you even consider adding more instances to them. So that's the reason. And I also talked about those NoSQL databases, right? When I said that they were more scalable, I meant in terms of horizontally scalable. So you can just add more servers and then the data can be partitioned throughout with sharding, and it'll still be just as performant. And I guess a really simple explanation for why that is because the data with these relational databases are related, and so you kind of need them to be sort of coupled together. And whenever you do some of these joins, right, it might be kind of complex to have when you have a bunch of different servers. But with these NoSQL databases, right, it's not relational at all. All you do is just you have data on here, data on here, data on here. They don't really care about the other data. You just want to know where one of them is. And yeah, that's a little bit why you'd want to consider horizontally scalable designs. Then maybe you'd want to consider a NoSQL database. Cool. So now I'm just going to talk about the CAP theorem. And this is pretty big, especially with distributed systems. If you don't know what distributed systems is, right? Basically, how do you make something scalable and good? Very basic definition. But yeah, you're going to see that a lot with system design because with system design, you kind of need to have distributed systems in your head while you're thinking of it. So this kind of also, I guess, doubles as a distributed systems lesson. But yeah. So consistency, right? I'm sure you guys are pretty familiar with this. If not, the name is pretty straightforward. Essentially, the data you receive from your system should be up to date and the same across all instances. So if you have any replications of that data within your system, it should be the same across all of them. And if I ping any one of those servers, the data should be the same across all of them as well. The next thing is availability, right? So every request you receive should always give me a response. Like your servers should never be down. It should always give me something. And the next thing is partition. And so what I mean by this is that if your data is just partitioned across several servers, it should just work well. So your system should just work well with those servers as well. Um, so yeah, you should always keep these in mind. It would be really nice if we could have all three of them, but it's actually not possible to have all three of them. Oh, I guess this isn't in here. But yeah, I'll just talk about it now. So you can actually only have consistency in the partitioning or availability in the partitioning. Right? You can't have all three. Um, and there's a reason for that. I won't go into it because for time. But yeah, so you can only have consistency and partitioning or availability and partitioning. So whenever you're designing something, you should keep that in mind, right? Whatever constraints you have, right? Maybe you want the data to be up to date across everything, because if it's not up to date, then your system can fail. Um, However, maybe you just want to have availability, right? Maybe this is just more of a user experience kind of thing, right? For example, with social media, um, you would forget about some of the consistency, right? But that's fine because if I upload my picture in America and one of my friends is in, I don't know, Japan, they're not going to see it right away. Maybe they're going to have to wait like a couple of seconds. And that's not really a big sacrifice there. That's okay because in that case, you're going to have availability. So everyone across the world will still be able to use your data or your system. So again, yeah, depending on what system you're making, you should choose and prioritize consistency or availability. Not necessarily partitioning because you can still do partitioning with availability and consistency. Um, so you just kind of have to pick. Cool. So now we're going to do a little bit of a design dive into deguzman.cloud. And yeah, here's just a picture of that. I'm just going to move this a little bit over here. So yeah, the first thing that I have is the load balancer, right? Um, this is good because I have a bunch of different services that are up, and I want them to be capturing the requests correctly. And I have Nginx set up, and I'm going to X out of this. Right, so the first thing that I have up here is just deguzman.cloud, and that's just the main landing page. There's nothing really that it's doing. It's just capturing your request and it's just giving it a web page back. So nothing super crazy there. Um, but then I also have this QR code generator. And so I have two endpoints for that, right? Post is when you're uploading or creating the actual QR code, and it has this endpoint and it has a post request, right? Post request because you're going to be creating some resource. And when it gets that, it gets your request, processes it. If it's okay, then it'll make another post request to this other service that I have. I'll explain that. Well, I guess I'll just explain it now. But this is basically just an object store that I have. Um, Very simple. It only has a couple of actual endpoints. But what it does here is it uploads it to the data storage solution that I have. And I'll go more into what happens when you upload it. But just know for now that whenever you want to create a QR code, you hit this endpoint here, and then qr.deguzman.cloud. It's another endpoint to actually create the QR code, and then it just returns that. Yeah, and then there's this other get request here for a specific ID of the QR code, right? So whenever you created a QR code, it gave that some sort of ID. And so that was specifically so that when you query the endpoint again, it can just query the data storage solution with that ID you gave, but this time as the key. And if it exists, then it'll return to you whatever QR code was stored. So now we're going to go over this actual data storage solution that I have that I've been talking about and just been kind of abstracting away. Um, so the first endpoint is the upload endpoint, and we saw that here with the write whenever we wanted to create a QR code. So what it does first is it writes it to a volume. And I won't go over what a Kubernetes volume is. That's not the point of this. But just knows that there's some storage that it has, and it writes it to some directory in there. And then the next thing that it does is it adds a file to this files table that I have in my Postgres database. And this is more so that whenever I get an actual key, I can just sort of look that up in here and then read it from the file path that I have. Um, and yeah, so that was the get request and that was the post request. And then I just have a get request for listing files. There are some sort of query parameters as well that you can attach to it. And then it processes that. Maybe you want to get a list of files by their creation date and whatnot. Um, and then it'll just query this Postgres database for all the files that you have, do the processing on that, and then return it. And then lastly, I just have a little heartbeat, and this is for my monitoring service. So every like 1 minute, it just sends it a heartbeat, and then it'll just write some heartbeat to the heartbeats database. I'm essentially just checking if everything is working, right? Um, and so that's kind of the main point of this endpoint. Yeah. And then the last thing that I have is this static server that I have right here. Just one endpoint, right? It's just get slash file name, and then all it does is just read from some Kubernetes volume, and if that file exists, it'll return you the file. So this is what I have, at least for the services that I wanted to show. Well, there's a lot more, but wasn't going to get into all of them. And it's also not the most complex, right? A lot of them are relatively simple. And the main reason for that is because there's no need for me to add a random cache or like a CDN or an async queue there, right? I think it's only more performant at a certain level. If there was only one user here, does it really matter if a quarter of a millisecond happens between adding a cache and not having a cache? To me, no, right? So I just opted for simple design. And that's what I think you guys should have in mind whenever you are designing something. Don't make something super scalable and highly performant when it doesn't need to be. Only do it when you have to do it. Cool. So another thing is my senior project. It's called Boshi. This is also hosted on deguzman.cloud. It's a little bit more complex, and I'm just going to show that right here. So the first thing that I have is the load balancer again, right? And we have several endpoints. This is actually kind of tiny. Can I zoom in? I'm just going to zoom in through. Oh, let's see. Okay, never mind. Hmm. Among Preet Kapoor. I think I can do that. Okay, well, we're just gonna make it super big. Oh yeah, there you go. All right, cool. And then I'm just gonna whatever. Okay, so the first thing that we have is the load balancer, right? And that's right here. And that's going to capture all of the requests. And so we have a backend. And what we do in the backend is that's at boshi.deguzman.cloud/API. And so there's this little asterisk here. I'm essentially saying that anything that's after this slash API will be handled by boshi.deguzman.cloud. Let's see, can I go more? Yeah, great. And yeah, when it gets it, right, there are several endpoints that we have. So the first, again, is the heartbeat, and that's just so that my monitoring service up here can actually see it. And then again, just verifies that all the systems are operational, and then it just returns either a 200 status or an error. So the next thing that we have are these endpoints right here. Um, and I'm not going to go into exactly everything that this app does. I'm just going to tell you exactly what these endpoints are doing, right? So this post here is just to, or I guess these two email endpoints are the post. It sends a code to your email, and then the put just validates that the code that you gave with the email that you also gave is correct and hasn't actually expired. Um, so you can see here that it writes something to a database, and then it sends your email through some SMTP server. If you don't know what an SMTP server is, don't worry. It's just used to send emails. Um, so the put request will then get the code that you gave, and it'll check if the email and the code match within the database, right? If they do, everything's great and happy. If they don't, you get rejected. So yeah. And then the next thing that we have is a get request for the OAuth client metadata JSON. And this is just for the OAuth that we use here on the front end. So whenever someone logs in and that process begins, we can get the configuration from the back end. Cool. And then let's see. Yeah, for the front end, right, this is just going to handle everything from the root except for slash API. So any of these subsequent pages will be handled by boshi.deguzman.cloud. And what's interesting is, well, I guess you guys don't really need to know this, but we're using Flutter. So the routing actually doesn't happen uh, on the back end or on the deguzman.cloud Nginx proxy. It actually just gets directed to the front end. And then since this is a single page application, the routing is done internally by Flutter. Uh, so, for example, we have the slash login page right here. And essentially what that does is it goes through the OAuth process of getting the client metadata JSON. And then there's just some more OAuth specific terminology that I won't get into because that's not what this workshop is on. But essentially, it goes through some accounts, right? So maybe you're signing in with Gmail or something like that. And then it goes to the OAuth authorization server to make sure that you're actually allowed to say who you are. And then we just get some more data for that. So we get some tokens and whatnot so you can have a persistent session. Yeah. And then once all that happens, you just get sent to some redirect URI. And yeah, then you can begin using the app. So we haven't had, didn't really write out all the routes here, but essentially, let's just say that we had like a slash post uh, or something like that. And that was hidden behind some authorization guardrail. What would happen is we would just hit the authorization server and then just make sure that everything's good. And then we would continue with that request. Yeah. If you want to know, you can go to Boshi dash app. Oh, that's not how you spell that. Yeah. Uh, Boshi dash app dot Uh, but yeah, I'll get into this at the end if you want to know. But yeah, and then we just have yeah the marketing page, right? This is literally just a landing page. Uh, that part where it asks you to sign up isn't actually functional yet, so don't or you can't actually get notified yet, so don't worry about that. But yeah, right. This is just the marketing page, and this is just a simple web application. So yeah, and the interesting thing about this is the backend isn't actually very complex, and that's because we use something called the app protocol. I'm not going to get into again what the app protocol is because that can be its own discussion, and it actually is. That's what the next workshop is on, so you guys should definitely come to that. But essentially, the app protocol decentralizes like social media and whatnot. So all of the components that would normally be held on the back end, for example, like the user information or maybe things like all the post information isn't really going to be stored on the database, right? We're still going to store some things, but just not everything, because that can all be abstracted away to somebody else hosting it or using some other servers. Yeah, and then we just have some microservices here, right? So the point of this Explorer microservice is essentially to grab all the data from the app proto firehose. And so I mentioned that app protocol is decentralized. Um, and I guess some context on that is the data can be hosted anywhere, right? Because it's decentralized, that doesn't mean that we get to host all of it. So somebody can maybe sign up with their own self-hosted data repository, which means that they get to own their data. And the way that then these applications would get that data is with something called a relay. And the relay basically aggregates the data from all of the data repositories, and then it provides it to the applications through a fire hose. So the Explorer is just listening to the fire hose and getting all the data that is relevant to our application, and then adding that to the database. And now that we have all the data that is relevant to our application, we have another microservice called Tourbillon. And what Tourbillon does is it just generates the feed based on the posts that are in the database, right? So it grabs it. Maybe you have some sort of algorithm that you want, because that's another thing you can do with the app protocol. You can choose the algorithm that provides you the data, as opposed to something like Instagram or Twitter, which just has it specifically for you, right? Maybe you want to have an algorithm that only includes LeBron James posts. You can do that with the app protocol, right? And so the Tourbillon's going to get that. It's going to consider your algorithm, and then it's going to give it to you. And yeah, I think that's all that I have for the Boshi system design. I'm going to jump back into this. Well, actually, I'm just going to, yeah. go into something else, right? So a good interview question for system design, because this is something that they ask in interviews, but it's not very common, right? They ask it sometimes in new grad interviews, not very often in internships, unless you're doing some like startup. But I think for like big tech internships, they don't really ask system design too often. And it's also not that common for new grads as well, because they're not really expected on the job to be designing these applications. This is more so for senior engineers who have more experience with actually doing this in production and whatnot. So, yeah, not as common, but this is what it would look like if you were trying to do something, right? And this is just from one of the mock interviews I did with one of my friends, right? So you'll see on over here that there are some calculations that I'm doing, right? That's a pretty typical thing to do because, like I said, you should always consider the constraints within your system, right? So with WhatsApp, there's going to be like let's say 100 billion messages a day, because yeah, 1 billion daily active users, um, which is actually like insane. But yeah, WhatsApp gets used a lot, right? And so there's going to be a lot of things that you need to consider, right? Like a lot of data written and read per day. And so you need to consider that in your design, right? So you can see here that there's the user and that they're hitting the load balancer here, right? And for simplicity, you kind of just ask, okay, what like major parts of this app should I actually consider? Because these interviews are only about an hour long, and WhatsApp has like a million features, right? So you kind of just want to get to the core of that. And so the features that I considered were sending messages, reading messages, and viewing profiles, because at its core, that's what you do on WhatsApp, right? Maybe you can also like, I think there's also a feature to view stories, face like video call and whatnot. But yeah, I think having three endpoints is fine. And then you have the load balancer, right? Like we said, that's going to take all of the incoming requests, distribute them to the correct services, and also balance them in between the servers that you have that are handling all of these services, right? So the first thing is maybe you want to send a message, and then you'll take that and give it to the sending service, right? So the first thing you might also want to do is hand this over to a task queue, where then the task queue can sort of ping the notification service um, instead of directly doing that here. Um, and what's nice about that is it kind of makes it a little bit more fault tolerant. So if the service goes down, then the messages that were going to be processed can still be processed instead of them just being lost in between. Um, and then there are also some duplicates here, right? Maybe you want to have um, just more replicas across that so you can send more notifications. And then, right, reading service, a lot of people read messages specifically also when you open up a conversation, right? There might be like 5 or 10 messages that you open, and then as you scroll up, you're just going to be retrieving more and more data. Um, and so, yeah, there's something that sits in between the reading service, and that's the Redis cache. Remember what we talked about, right? So we want these reads to be as quick as possible. And I think what I did here was the read service will first hit the Redis cache. And if the data that we want to receive isn't actually there, then we'll get it from our NoSQL database. Um, and again, NoSQL here just because it was more horizontally scalable. And I found that to be a little bit more necessary because there were just so much data being read and written every day, right? You can see here terabytes a day. Um, and yeah, doing that with a SQL database just may not be as practical or as maintainable as with a NoSQL database. And then you can also see that there's just some blob storage here, and that's just for maybe you want to send some images or videos, or maybe you have a profile picture, and that would just be stored on that end. And yeah, the reading service would just grab it from the cache and then return it. And then for the viewing profile as well, pretty simple, right? We're just going to have a profile service. It's going to aggregate what it needs from the cache. If it's not in the cache, then it'll look out to its SQL store or NoSQL storage, and then the blob storage. Uh, and yeah, that's kind of what I have. A good resource that I really read on when I was trying to study system design is this thing called the System Design Primer on GitHub. Uh, it goes over a lot, and that's kind of what I referenced a little bit when I was doing this workshop. So yeah, there's a lot of things. I think it's great, especially if you've never done system design before. It basically just says what I did, but a little bit more in depth, right? So it goes over availability and consistency, and then also the different kinds of consistency patterns that we have, right? I kind of just mentioned consistency, but I didn't go over weak, eventual, or strong consistency. And then there's also some availability patterns. It also talked about some components that I didn't include, like a CDN or a DNS. And then, yeah, it just goes a lot more in depth than I have. And yeah, it might take you a couple days to read through this. Um, yes, especially if you're not really familiar with some of these, it might be a little bit longer, but I think it's a really great introduction to all of these components. And if you do have a system design interview, I definitely recommend checking this out because it was very helpful for me. And yeah, they also have study questions with some answers as well. So if you want to reference those as you work along, then you can do that. And one thing to note as well is that there's not like one correct answer with your system design as opposed to leak code, right? Or I guess even with leak code, there's a bunch of different answers, and it's kind of the same here. So if your cache is placed somewhere else instead of like in between whatever, um, that's okay. If it's considered scalable and your interviewer likes it, and that's all that really matters. Um, and that's all I had to talk about today. I hope you all enjoyed. Uh, and if that talk was very exhausting, we have food up here. And yeah, we have this room for the next 30 minutes. So thank you all for coming. I'll also be here. So feel free to talk and chat. Oh, yeah. Any questions? Oh, yes, you can sign in. So it should be. Oh, okay. Yeah, should be up here. Cool. Yeah, I do not. Yeah, yeah. If I have a what? Ah, I was I tried to do that a little bit back, but it's actually more complex. It's like not very simple. So I didn't feel like doing it. It was gonna take like a couple hours of setup, and I was like, eh, I'll do that eventually. Yeah, and we haven't really found a need to do it yet. But if we ever do have to for our application, then I'll set it up. But yeah, I found this like super long article that talked about how to go through the setup, and so I was like, okay, when I feel the need to do this, I'll do it. But yeah. It took me a bit. So the reason for that, I guess maybe it took me like a month, I'd say. I think this really got going over winter break because that's kind of when I had time. I had the idea of it and I started executing it a little bit before summer break. So I bought the Raspberry Pis in like May, but then I was away the entire summer because of an internship, so I couldn't really set that up. And even if I did have the time, I was just pretty busy. Um, and then I got back, but I only had like a week, so I didn't really get to set that up either. But then finally winter break came around and I was like, okay, great. I have a month. Let me just go crazy with this. And yeah, that's when I kind of learned a lot more about it. And the reason was because a lot of the components that I needed to set up with it, like Kubernetes and whatnot, I just was a little bit unfamiliar with. So I had to go into all of that, learn a lot of it. And yeah, once I did, things were set smooth and or smooth sailing from there. And yeah, yes. Oh yeah, I think I had, let's see. Yeah. It's my cluster of servers that I built with three Raspberry Pis. And then I just have a bunch of services that I have hosted on there. Yeah. Not just images, just like any file that I want. Yeah. So I think I have my senior project on there, like our presentation. So if you go to like static.deguzman.cloud and then you go to, or I guess I also have my resume on there. Yeah. Slash resume. Um, then I also have just a PowerPoint on there. Let's see, PDF. Yeah. and then it'll just download this and show all of that. Yeah, so if you guys want to look into what Boshi is, you can just go to that URL. Uh, yeah. Uh, yeah. I'd say that most of them are RESTful. For the static file server, I just used Nginx because it's pretty easy to set that up. You just spin up an image of that, right? Like a Docker image they have, and then you just connect it to some volume so that it can actually write and read the data. Um, and that's kind of just what makes it persistent. So yeah. Yeah. So like if the server or like if the image ever restarts, right? Because that volume is just hosted somewhere else, it just connects to it and then it can give it back to you. Yeah. Yeah. Yeah, I have external storage for now. It's like I just bought some cheap like USB drives. But honestly, I think I'm gonna upgrade that soon, just to have more reliable storage. So yeah. Yes. I think they're pretty good for now. I don't really have anything that's demanding more scalability in terms of like vertically scaling. I think just having more storage on there, because in total, I think it's only like a couple hundred gigabytes, but I want to have at least a couple terabytes on there, because I want to just have like a photo server on there as well. Um, it's kind of like Google Photos, but self-hosted. Uh, and yeah, there's just a bunch of cool things that you can also self-host. And I don't want the storage to become a limiting factor, which it kind of is right now. So. Yeah. Yeah. Okay. So the Color Stack Minecraft server, uh, a while back, one of my interviewers for one of the company I was interviewing for was like, you should check out Oracle because I told him about deguzman.cloud in my Minecraft server, and I was like, okay, cool. And he was talking to me about how great it was, uh, and I thought that was like a little secret between us, but apparently the whole world knows about Oracle's free tier and how great it is, um, because now I can't get any of the free instances because they're all hogged up, and the only one I could get was a 1 gigabyte RAM computer, which is absolutely atrocious. It was like barely handling me SSHing into it. So, yeah, unless I can grab one of those good free servers, it's not looking good. So, yeah. Any other questions? Yes. I'm so glad you asked. Yeah. Yeah. So yeah, there's also just a bunch of great resources on YouTube as well. This one guy that I used to watch a lot, his name is, I think, Jeff Geerling. I think that's how you spell his name. Yeah. He just makes like a bunch of Raspberry Pi things. And there's just like a whole community on YouTube that kind of, yeah, he can like, yeah, he like gives a lot of inspiration and whatnot. And there's a whole bunch of people like him. So yeah, yeah. Yeah, so the first reason was I just wanted more money. Second one was the location. I'd been in Seattle for a couple years, and I wanted to just go somewhere else. And the one place that I had in mind was New York, and I'd been wanting to live there for a while. So like this season, I basically only applied to places that were in New York, and then a couple that were in the Bay. But I didn't apply anywhere in Seattle. And luckily, I got a couple offers in New York, and I chose Datadog. So. Yeah. Yes. What was that? Uh, they might have, but I didn't really try because I didn't want to stay with Microsoft anyway. I kind of decided at the beginning of the summer that I wanted to move to another company. Um, so I didn't really attempt that either. But yeah, also I guess with that might have been possible. But yeah, I just didn't look into it. Yeah. Yes. All right. Let's just uh I think one thing that it makes me stand out is the projects, right? I mean, besides the experiences, like I think the projects are pretty unique. Right. So I have deguzman.cloud on here, and then I have the things that I worked on for Swamp Packs, and I just have another thing that I made with one of my friends. Um, oh yeah, I dude, there was not too much room. Um, yeah, I think that's what makes me stand out. I think if you go to, I think it's week 6. Yeah, there's just a bunch of so for the DSA discussion, this past week we were doing mock interviews, and then I just left a bunch of tips in here. And the first tip that I had was that the projects would make or break your resume, and so that's truly what I believe, especially if you don't have that experience on there. So try and make them unique, try and make them about something you're passionate about, and then also just try and learn a bunch of technologies. Um, like I don't think this one is too important right now, making products, right? But just make something that you enjoy, is unique, and you'll learn about. Yeah. Yeah. So the way that I find time is that I'm a senior, and the only classes that I'm taking this semester is ceramics and guitar and senior project. Yeah, ceramics and then guitar. Yeah, not like a ceramics and guitar mixed class. Um, but yeah, because I've set most of this up within the past couple of weeks or like past couple of months, ever since I just started chilling, right? I didn't really get to develop it, like I said, until winter break, because during last semester I was taking real classes, and I was also doing a job search, and I was also involved in a bunch of extracurriculars. And then over the summer, I was just doing Leet Code, hanging out with friends, and then doing my internship. So I didn't really have too much time. And so that's why I really just went all out on it during the winter break because I was like trying to scratch this itch that I had for a while. Um, so yeah, luckily I have free time now and I get to work on this and just put up a bunch of stuff. So yeah, yeah, yeah. I think I also had a decent amount of projects on there as well. So I had like one of my projects that I can remember was like I made this tic-tac-toe AI bot that was like unbeatable. And this was like before GPT, so I didn't just ask GPT what move should I go for next. Like there was this thing called the Minimax algorithm that I looked into, and it just kind of calculates what the most optimal move is. So I made that, and then another thing that I did was like a data structures and algorithms visualizer. This is before I took data structures and algorithms as well. I made this in Roblox, and it was like, yeah, I was really big into Roblox. So I did like a visualization of Dijkstra's algorithm and like DFS, I made a Reddit post on it in like r/Roblox or whatever, and it kind of got like kind of blew up. It got like 600 upvotes. So. Yeah, I put that on there and then just like some other projects that I don't remember. But yeah, I think those were what made me stand out. I remember that one of the interviewers for my first internship said that she was excited to like interview me because like of the projects on my resume. Um, so yeah, I think that those made me stand out. You do? Oh gosh, it's kind of embarrassing. Yeah. I did put Minesweeper on there. Yeah, no, they weren't like raving about Minesweeper, but they were curious about the other ones. So, oh, so I was the summer before college, right? I wasn't doing anything. So I was like, let me just learn and do a bunch of stuff. So I just did that. Uh, yeah. So I just basically take advantage of any free time that I have to build and just have fun, right? So like whenever I have a spring break or maybe like Thanksgiving break or something, I don't have to like really worry about school, so I can just go ahead and do that. Yeah. I use ChatGPT sometimes, like more specifically for things that I just can't really find any resources on or like might be a bit difficult. So for things like Kubernetes or just some like things like Nginx that I find like I'm not too familiar with, but I know that like ChatGPT can give me a pretty good answer on because the questions are relatively simple. I do. Sometimes I do it with TypeScript as well. Sometimes like I have these really random like use cases that I just can't find on Google. So I just ask and see. Uh, it usually doesn't really help with those more niche cases, but it like pushes me in a direction where I'm like, oh, okay, maybe I can do this or I can do that. Um, but yeah, I usually just ask for that. I usually do just because I find whenever I ask ChatGPT to do something, I kind of just copy and paste it, and then just if it works, I just go on about my day. And then I find that I don't actually internalize that and get the knowledge that was required for that. So sometimes I just ask like, okay, why did you do this? Why did you do that? And then like that sort of helps it. Um, but yeah, I think maybe for like one-off cases for like some random thing that you're only using once, it might be useful. But I think if you want to learn something that's actually useful, so maybe you want to learn web dev, right? Maybe don't just go and ask ChatGPT, make this website for me and whatnot. Like it's good to go through the fundamentals of that, and then get the knowledge to a point where you don't have to rely on some chatbot to code and you can do it yourself. And you can still ask the chatbot things, right? Like I still do, but it's not all the time to the point where I'm relying on it. It's just to the point where if I have a problem that I'm kind of stuck on, I might just ask and then it might lead me in the correct direction. Yeah. Yes. Uh, don't think so. So I'll just walk you through the ones on my resume. So for UF courses, my friend and I were just talking about how we thought that the what's it called? The UF website was a bit slow on fetching courses. And so we thought that we could just make something a bit better. So we did. Um, and what was cool about this is that they put us on the Alligator, which is like the Gainesville newspaper. And so now I have like a newspaper and the article on us. I hope to frame it one day. Haven't had the chance. But yeah, and then these two are just from Swamp Hacks, right? So this is just the landing page. I just put that on there because I thought it was pretty cool. And then Hacker was like more of a full stack project um, that I thought was also a bit niche. And I also hadn't seen it anything like it before. If you don't know what that is, it's just an admin and hacker shell. So it allows you to manage your hackathons and it allows you as a hacker as well to sort of manage your own profile and see what's going on. And then deguzman.cloud was just my own thing. It basically is. Because my friend, he also had something similar to this, and I was like, okay, I just want to do that as well. And so I just, yeah, just did this. It's also like a very fun niche to have. A lot of people have their own self-hosted servers. Um, and the mo main reason I did this was because I was looking on Namecheap for just like random URLs, and then I saw deguzman.cloud, and I was like, this is my sign to like do my own cloud thing. So yeah. Not much. I think for like the first year, they always give you like a really good discount. So it's probably like $1. But then for like maybe the year after, like I think year over year, it's maybe like $10. So, but still not breaking the bank or anything like that. So yeah, I like using Jake's resume. Um, I think it's just well accepted and known that like it's pretty ATS friendly. So yeah, good template to have. Cool. Thank you. I don't think I've ever been to a summit or a conference. So no. All right. Yeah. I don't think so. I don't think. Wait, I'm gonna stop the recording now. Okay.